Here is the next example. I asked this example in one of the previous exams. So I gave you the complete state equation, output equation of a system. Okay. Now he's asking about find the model is stable or not. Okay. You can call this as a model. I mean, it's not going to make a big difference. So it's a stable. So he's asking about whether this model is stable or not. So to find the stability, we're going to find Si minus A. Okay, so Si minus A and find the determinant of Si minus A, which is called characteristic polynomial equation. So I found that the characteristic polynomial equation, I found that S equal to 1, S equal to minus 2. So based on our conversation, as long as we have a pole, if we have pole on the left hand side of the y-axis, all the poles, if we have all the poles on the left hand side of the y-axis, then only the system or model is going to be stable. So here I have a pole at minus 2, a pole at 1. Okay, so for sure I have unstable pole here, so this system is not stable. It's an unstable system. Okay, that is clear. Now the next point, we're going to do controllability. So to find the controllability, we're going to find PC equal to BAB. So I found the AB value and find the PC. I found determinant of PC equal to 0. So if the determinant of PC equal to 0, the given model is not controllable. Okay, I just explained if the given model is not controllable, expect a pole zero cancellation. So to find the pole zero cancellation, we need to find H of S. H of S equal to C times Si minus A inverse times P plus D. In this case, the D matrix is 0, so that's the reason I didn't do D matrix. So we already found Si minus A. Somewhere here, I found the Si minus A. From the Si minus A, find Si minus A inverse. Okay, and then multiply with C, multiply with P. I found that H of S equal to S plus 2 over S minus 1, S plus 2. So here I have S equal to minus 2. That's a stable pole. It's a stable pole, but it is uncontrollable pole. That pole is uncontrollable. Okay. Now I'm going to use the partial fraction to find out AB value. Why am I finding these values? Because I'm finding these values because I can draw the simulation diagram, since in the question he asked for the simulation diagram. So choose two poles. So he's also asking us to choose the two poles. We'll do that. The model will have a solution, so that the model will have a solution, and also draw the simulation diagram. So since he's asking for simulation diagram, I found H of S. I did the partial fraction. I found the individual poles. Now you saw that this model is not controllable and it's not stable, and I found that uncontrollable pole is S equal to minus 2. Now look into the flow chart, the given flow chart here. So here is the flow chart. Is this model is controllable? No, I found that it's not a controllable model. Now find the controllability and also find the uncontrollable pole. I found that uncontrollable pole is S equal to minus 2. That's uncontrollable pole. Now he's saying that to have a solution, you have to choose are the uncontrollable poles among the desired poles. So you have to keep this pole as it is. Then only the solution will exist. So when you choose the poles, make sure you keep this S equal to minus 2 and change the other pole. So the actual poles are S equal to 1 and S equal to minus 2. Now when I choose the poles, make sure I keep S equal to minus 2 and change the other pole. Okay, then we will end up having the solution. Okay, so I found AC equal to A minus BF, and I found SI minus AC and found the determinant Okay, and I found characteristic polynomial equation here, which is s square plus f1 plus 1 of s plus 2f1 minus 2 equal to 0. So that's a characteristic polynomial equation. So with the desired poles, I have s plus 1, s plus 2 equal to 0. So s square plus 3s plus 2 equal to 0. So when we equate these two characteristic polynomial equations, so f1 plus 1 must be equal to 3. So f1 plus 1 must be equal to 3. So f1 equal to 2. And 2f1 minus 2 must be equal to 2. So based on this, f1 equal to 2. So f1 equal to 2 and f2 can be any number to have a solution. So I found the solution. Now he is asking us to draw the simulation diagram. So based on h of s, I draw the simulation diagram. So the green one is the actual system. Okay, now I'm designing a state feedback. So I have access to the state. So here is the feedback f1 and f2. So f1 equal to 2 and f2 equal to any number. So there are many solutions. You can choose any number. Okay. This is the whole simulation diagram for the given system with the state feedback. Thank you.